Hello everyone, welcome back to the workshop and part 2 of our BSA Bantam Yamaha clutch conversion. This video is all about modification of the parts. We do quite a bit of machining and hopefully we'll make significant progress. We're not going to get it all done in this video. It is going to be a 3-part series, so yeah, hopefully we'll get it all finished off in part 3. Couple of words about the channel. We are now on 490 subscribers, so a very sincere thank you to all of you. You're helping to make my channel a success, and also I love doing this stuff and it really motivates me to put the camera on when I think that there's an audience out there that wants to watch the stuff I'm doing. So yeah, thanks very much indeed. It is very much appreciated. Other news, this month we did actually manage a mention in Britain's best-selling classic bike magazine. I won't name it, but I think you can draw an inference from that description. Yeah, we actually did manage to get a mention. So in the technical section, there's reference to the BSA Bantam crankshaft end float video that I did. I think last year I did that when I was working on the D7 engine. So if you do happen to buy that magazine, yeah, watch out for us. We're in there somewhere. Fame at last. Hey, I'll try not to let it go to my head. Right, enough of the customary waffling. Let's get on and do some work. Well, we overcame the work holding problem for clutch drum. You recall from the last video I didn't want to mount on these fingers because they're quite fragile, and this material I think is quite a high zinc content aluminium alloy. It's quite soft and quite chewy, so I didn't want to hold on here, one because they'd get marred up, and two because I think that they'd probably snap off. So I was thinking about using the faceplate, but yes, again, the faceplate is the bridesmaid and not the bride. I found this piece of 6mm aluminium plate. It could have done with being a little bit bigger because we're quite close to the chuck jaws there. Hence, I've mounted it on a cylindrical parallel, which I machined up out of a piece of scrap. So we're slightly off the plate. We've got 3 M5 screws. I threaded the original rivet holes, and we've got 3 M5 long screws securing the whole thing together. So that worked anyway. It took a little bit of clocking in, but we got it to within a couple of tenths. And as you can see, I've already machined this step off here. So let me grab the chain wheel. The chain wheel fits nice and flush. It's a good fit. There's no rock in the register, which is good. And you can see on there's kind of a machined, to get it in the light, there's a machined face, a mounting face, and then the sprocket kind of slopes away. Well, that face is a really good, if I get it back in, there we go, a really good snug fit against the clutch basket. So I'm happy with that. And now I've got an old primary chain here. If I just drape that over the top, you can't see very well from the angle that you're at. So what I'll do is I'll move you. Let me just switch the camera off. I'll bring you around and give you a better view of this primary chain. Well, I've got you on my brand new tripod. I treated you. I thought it was about time I got a decent one, because the old one was like, well, it was standing on FM aerials basically, and it was a bit wobbly. So we've got this new one. We'll see how we get on. Right, let me grab the chain wheel because we're going to have a look at this this gap for the chain. So if I put the chain wheel on like that, you can see that there is a little bit of a gap here, not much. And if we just lay, this is an old primary chain that I've got, if we just lay that over it, it's fairly obvious that it's, well, maybe it isn't to you, but it's touching just below the rivets on the inner edge. So if that were to run around like that, it would scribe a line like that. So we need to create some relief. Put that back on the bench. No, we've got incoming. So what I'm going to do is, I think I'm going to use the parting tool. I'm just going to plunge in and just create a step for that chain to run in, just to give it some clearance. And I think we've got enough depth on this, the back end of this casting. We've got a couple of mils, so I think we'll be safe. And I think that's what the other people did as well. The other people that have done this conversion. So I'll get set up and I'll get that done, and then we'll have a look and see what it looks like. Right, here's a view for you. I'll move the camera in a minute so that you can see the effect. Let me just bear with me. Let me just change the angle. There we go. So we've gone 2.5 millimeters back, the depth of cut 2.5 millimeters, and we've gone in about 5.5 millimeters, and that's given us enough clearance. I did think about just spacing it out from the back with a shim, but then the conversation we've had in the past about spline engagement and all the rest of it, I'm trying to keep this assembly as compact as possible. Obviously, the more we space out the assembly, the more we'll have to take off the clutch fingers to make it clear the casing, and I want to keep that to a minimum as well, because obviously I want enough effective length on the clutch fingers so that the clutch operates properly. But let me just move you and we'll have a look at the effect. Okay, now you're back in the tripod. I appreciate the view's not quite as focused, but I think you'll be able to see what's going on. If we offer up the chain wheel with the chain fitted, you can see that there's a good about not quite a millimeter, but not less than 0.5 millimeter gap there. It is rocking a little bit because I've not got it held up as hard as I need to, but it isn't touching, and that's with the chain all the way across on the teeth. We've got clearance, so I'm happy with that. We shouldn't be eating into our clutch basket with our primary chain, which is never a good thing. So I think we can take it off the fixture plate now and move on to the next step. Well, this could take some time. As you can see, I've made a bit of a fixture to turn the BSA clutch hub down. Let me just finish this cut and we'll talk about it. So it's a piece of aluminium, bit of 70-75 that I'd lying around. And I've chosen aluminium because if this thing spins, if it loses grip and it spins, and it was steel, it would destroy the splines inside the hub. And it's the splines that we want. We want to get rid of all this outer area and get down to a smooth diameter, but we must preserve the splines. That's what we're after. So I used aluminium because if it spins up, and this is only sort of clamped together with friction, really, it's a good fit on the mandrel, a really good fit, but it's just clamped up with friction, and if it spins, it'll just chew the aluminium, take the aluminium with it, and we won't damage the spline. So this is a bit of a delicate operation, and I think it's going to take a long time. These things are super hard, and I've had it in the heat treatment oven at work to try and take some of the temper out of it, and it'll be going back into the machine shop for rehardening once it's done. But I get that some of you guys won't have that facility, but what you can do is just get it up to cherry red and then let it cool, and you'll take some of the temper out of it, and then you can just heat treat it back. You could case harden it if you wanted to. I think, in all fairness, just one annealing at cherry red will leave quite a lot of the hardness in it, and you probably get away with it to use it as it is. But yeah, this is going to be a long drawn out process because we only take tiny cuts, and the carbide seems to be holding up, but I think it's going to muller this tip. But if we, if it costs us a tip, then so be it. But anyway, let me do another cut, and I've already taken a bit off this end. I'm just practicing. I'm just getting it evened up so we can take a full length cut rather. But it is taking it off. But you can imagine it's a hugely interrupted cut, and yeah, I think the tip is going to perish, but we'll live with the cost of the tip, I think, just to get the job done. What I don't have is a cylindrical grinder or any access to a cylindrical grinder, but I suppose what you could do, if you wanted to, is just grind it down on a bench grinder. Oh, I think we're going to end up taking a full cut here, which is good. Yeah, you could do it on a bench grinder, I suppose, but my bench grinder that I've got in here is not really up to the job. So I think we're going to be here a while. The method of the work holding, it won't bear, brave cuts really. I think it actually started to spin now. So you could be just about to witness the failure of this method. And if that's the case, I'll probably have to take it into work and grind it on one of the big bench grinders they've got in there. Okay, well, we got right across. As I say, I'm not sure how long this is going to last. It may not work, but I'll keep persevering at it, and we'll have a look at it a little bit later on. Well, it's still holding on, and to coin the phrase of Mr. Double Boost, we're getting somewhere now. As you can see, these teeth, or splines, or serrations, whatever you'd like to call them, are much reduced, and the tip is holding up really, really well. This is my favourite lathe tool that I've got. It's a Seco knife tool that my brother gave me, and these Seco tips are incredible. It is showing a little bit of signs of abuse, but it's holding up. So I'm just going to keep going, and hopefully we will hit solid metal fairly soon, and then I think at that point we could probably revise the work holding method and go from there. But until we hit solid metal, I am going to carry on with using this friction drive setup, and just keep ploughing on. See you in a few minutes. Okay, that worked. I managed to remove all the splines. We've got a fairly uniform, if slightly rough, surface finish, but that's to be expected, I think. I wasn't optimizing the speeds and feeds. I was just going as quickly as I felt safe to go without basically ripping this thing from the fixture, which would have been counterproductive. So it took quite a while. I think it's about an hour's worth of turning in total, just doing it about 2/10, so a 1/10 cut, obviously 2/10 because it's 1/10 either side at a time, and it took me about an hour to machine that down, which I didn't think was too bad really. Got to get the thinking cap on now, because we need to work out how much more of this needs to come off. Here, this diameter here that you can't see, it's behind this washer, but I've got the pencil on it. This is the sort of spigot that sits in into the thrust washer, or thrust bearing rather. Let me grab, there we go, and get this in front of the camera. So, oh, you can't see it. When that's fitted to our clutch basket, we have our thrust bearing here, and then we've got that portion that I just showed you here. And that's a sort of a spigot that sits in here and locates itself in the center of the bearing. So we need to retain that. That needs to stay. And then we need to machine this down to a diameter dependent upon how much we can take out of our Yamaha hub. As I say, we've only got a certain length to play with. We need about 12 millimeters really, and then we need to figure out how much we can take out of here to create a bore for this to drop into, and then we're going to counter bore here, and then we're going to leave this with a slight hat section at the top that'll drop in and sit flush, and then that'll positively locate the new splined hub into our Yamaha clutch center, and then we'll devise a means of preventing it from rotating, because obviously it needs to transmit a positive drive from this this component to the main shaft. But I have some ideas in my mind for that. But the main consideration now is how much can we take out of here, and correspondingly how much do we need to remove from here. So I'm going to get my thinking cap on, and we shall do some measuring, have a look at it. Right, I've brought you back over to the bench, and we're going to do a little bit of measuring and just figure a few things out. And I thought you would benefit from seeing this step, and just a bit of head scratching on my part really. We'll go through the process together. So we've got some limiting factors, and all looks well on that side. It looks as though we can take as much as we need, but if we look at the other side, we've got some features that are going to cause us some problems. Just let me grab my pencil again, get you back into shot. Here we go, excuse me fiddling around. So we've definitely got this bit here, which is going to be a limiting factor. Obviously it's narrower here as well, so let me just measure those areas, because they are going to reduce our maximum diameter. So just do it roughly with a caliper. Let me just zero it. If I can get in there. Are you seeing this? I think you just about am. If I move my hand, it's so much better, isn't it? So what have we got there? Can you see those figures? 28.65, there or thereabouts. 28.60. So we call it 28.6, and then across here, if I can get in with these, I'm not sure I can get in with these. Oh yes, I can. About 29.5. So we don't want to encroach into this 28.6. So I would suggest the largest diameter we can afford is probably 25. So let's have a look at what 25 looks like. There's 25. Yeah, I think 25 is pushing it, to be honest with you. We're going to be right on the edges of those features there. So let's have a look at 23. And this is just me figuring this out because, as I say, we're diverting quite considerably from the methods that other people have used. At this point, we'd normally just be filing the existing splines, but I don't really want to do that. So there's 23 millimeters. Yeah. So if we go for a top hat of 23 millimeters, we're going to be close to the edge, but I think we've got enough meat there to do it. So that will be the top hat. And then the core diameter, which will be, I've just removed this from the chuck. You can see what it's fitted to. Look, it's just there's a thread that I practiced. Let me get it back into shot. When I was making the swinging arm pivot bolts, I practiced cutting the thread on here. Look, you can see I've still got that. But there you go. That's what's left of our BSA clutch hub. And if we measure this diameter in here, which is what I said was the absolute minimum we could play with, we've got, oh, get it into shot, 19.2 millimeters. Thereabouts, 19.2. So I think that's our plan, isn't it? I think we go to our 19.2. So basically we'll just we will literally just follow that that diameter. When we get down to that diameter, we'll just follow that diameter, and then we'll leave our 23 millimeter top hat up here. We'll get rid of, well, it won't even be up here because it's only about that thick. We'll get rid of our excess material, hollow material. We'll bore this out to a, let's have a look, what are the splines at? I could be talking rubbish because the splines might not allow it. Let's just get that. Oh yeah, we're all right, look. 16 millimeters are our splines. So we'll take out all of our splines when we bore out to 19. So if we bore out to 19, just over, so that we've got a nice press fit on this, we will put our 23 millimeter counter bore in here for our top hat section, and then we'll press the whole thing together. We'll have our new splines dead center because we've machined it on the lathe. We know it's dead center. We're not trying to make a camshaft. Drop it in there, and then we'll look at locking it, forming an anti-rotation bond, and we'll have a look at doing that a little bit later on. But for the meantime, we need to get our boring done. We need a decent way of holding this in the lathe without damaging these splines on here, because this is aluminium, and if this thing spins up, we'll lunge this and it'll be no good at all. So we need a good way of work holding that. I think probably some sacrificial pieces between the jaws and our splines. Probably clock it up in the forejaw with some packing pieces to take the pressure of the jaws off, and yeah, possibly drill it out to start with, progressively drill it out, and then go onto the boring tool, bore out to a good press fit, and then put our counter bore in. So that was a bit of a long-winded way of describing it, but you know, if you're going to use this series of videos to have a crack yourself, I think it's only right that I give you as much information as I can. Not that I'm saying that I'm right, but give you as much information about how I'm doing it, and you can obviously form your own opinion from there. Okay, we're back in the lathe, 1250 RPM. I've turned the tip around, and we'll see if we can do something about this surface finish and start hitting our diameters that we're looking for. think that's more than acceptable. More than acceptable. So let's just have a look and see how much we need to take off. We want to get down to 23 millimeters, don't we? Let me just zero up our caliper. Obviously I'll do it with a micrometer for reals, because we want to be accurate to our nice press fit. So we're just over 30 millimeters. A little bit to come off. So I will mess around and turn that down, and we'll come back when we're at 23 millimeters. And then we've got our portion that we need to machine down to 19.2, which is the diameter of our existing section. And we'll put that in, leave our top hat, and then that'll be our piece finished, hopefully. We are working on the Yamaha clutch hub now. We're about to do the spline portion. You can see that I've got it fixtured up in the lathe much in the same way as I did the clutch drum, using the screws for the clutch springs, good solid mounting, and a nice diameter here to clock in on. A little bit of chalk and talk, I hope you'll forgive me. I want to explain this next process because I've changed the plan slightly, or well, quite considerably really, and I think it's important that you know what we're about to do and why we're about to do it. I've already had a drill bit through here, as you can see. I've taken this out to 16 millimeters. We've almost got rid of the Yamaha splines. You can't see very well, the light's not great. Let me see if I can make it better. There we go. Yeah, almost got rid of the Yamaha splines. And what I want to do is make this larger than the gearbox shaft, so that we've got clearance. We're then going to pocket this out, basically counter bore it with a hard shoulder. And the reason why we're going to do that, and we're not going to do the top hat fit anymore, is because when you make the insert from the BSA hub, which I should have realised, and I should have thought about it a little bit more, you're limited, not on diameter obviously, because you can have as much diameter as you want, but you are limited on diameter here, so you can't really have as much as you want, but you're limited on depth. So there isn't really enough material to do a top hat, or if you did, it wouldn't be very good, quite frankly. And obviously this depth here is less than this depth here, so you would be compromised on spline engagement. Now, if we pocket this out and we press fit this in with some Loctite to stop it from falling out, and then I've got another cunning plan to resist the dark forces of torque so that it doesn't spin in there, but we'll come to that. If we do it that way, then we can have this flush in the back of here. We can have the bit protruding for the thrust bearing a la BSA, and we end up with exactly the same spline engagement as we had on the BSA, and we don't compromise. And I think that's probably one of the biggest compromises of doing this conversion, is that you end up with, you know, whatever splines you can get, basically. Once you've got your spacing right, you don't get full spline engagement, and then you've got to counter bore into your splines to fit a sleeved nut to get it all to go together. So you end up with, you know, hardly any spline engagement. Doing it this way, the way we're going to do it, you're going to end up with exactly the same amount of spline engagement as you've got on the BSA. So no compromise. And then if we need to counter bore this a bit and fit a sleeved nut to get it all to go nice and tight, we can do that. We don't compromise on thread engagement, which is, I think, another compromise that has previously occurred on this conversion. So we've killed two compromises with one stone, haven't we? We get full spline engagement and we get full thread engagement. So if it all goes to plan, obviously. So that's what we're going to do. I understand that that was 3 minutes and 38 seconds of solid waffling. I do apologise, but I just thought it was important to get this across and let you know what we're doing, and why we're doing it. So I'm going to just recheck our concentricity with the clock just to make sure that our drill hasn't moved us off center at all, because quite large cutting forces. Reclock us in, and I'll fit the boring bar and we'll get on. Okay, zeroed out on our boring bar. We're just under 16 millimeters at the moment. You can just let me just hear the spline, what's left of the splines. We're just collecting dust at that. So zeroed out at that, and say just under 16 mil. We want to go to about 18 millimeters. Close to 18 millimeters if we can get. That will give us enough clearance and room to make our shouldered nut when we come to it. So yeah, that's a mill cut. We'll crack on and take some material. I'm not going to go bananas with the depth of cut because I don't want to run the risk of knocking this off centre, which it shouldn't do, but you know, you just never know, do you? So we shall be careful. I'm fairly convinced that this is cast iron. It cuts just like cast iron. I wouldn't be at all surprised if it was. There's our first cut. I'll keep you with me for a couple of cuts, and then I'll switch you off so that you don't get bored. Yeah, just like cast iron. I think that's what we're playing with. Right, okay, we're on our way. Right, there you go, not zoomed in. It's a long shot, like many of the things that happen in this workshop. But anyway, I think we're at our 18 millimeters now. I went for 18. Our main shaft is just over 16 millimeters. That gives us about a mil per side. I'm not liking the feeling of that snap gauge very much. Let's try it again. I think we're right on the limit of this particular gauge. That was a bit better. Let's give it a measure, and then I'll see if I can get the micrometer to focus. Where are we at? Have I gone over? I think I might have gone slightly over. Oh, not by much. Not by much. Right, here we go. Here comes the fun bit, trying to get this to focus. Do bear with me. Can you see that? We're just a shade over 1801. So I think we can live with that, don't you? So the next step is bore out our pocket. Our little counter bore to take our insert, and I think that's 23 millimeters. I need to mic it up again just to be sure, but we want a good press fit, so probably want to be a shade under and probably warm this up when we drop this in. So that's our next job, a bit more boring work. Well, it's not that boring, is it? Quite interesting, really. Right, how about that? Look, 2 in a row, getting the micrometer to focus. I don't know what's going on. I must be living a charmed existence. That is our insert, and it must be that time of year because we've got another 01 or just under 23.01. So if we go for a shade under 23, we should get a nice pressed fit when we warm up our clutch hub. So that's our target. Right, the pocket is done. We're at 22.95, which gives us a nice N6 press fit. Our little piece here, our insert, just starts. I'll put a little chamfer, well, not quite a chamfer really, I've just taken the edge off of it, a chamfette if you like, just to give it a little bit of lead and just to take the edge off. So next job is to take it off, take it out of the lathe, take it off the fixture plate and give it a really good clean up, scrub it clean so that we don't have any problems with our Loctite. I will confess to a slight faux pas. When I started boring out the pocket, I didn't quite have the saddle stop tightened up, and my boring tool just went sailing through. So my perfect 18mm for my original bore is now about 18.2, but that's it's not a major problem. We can just adjust the size of the sleeved portion of the nut, but hardly best practice. But there you go. I am but flesh, and yeah, it was a bit of a moment, but it's recoverable, so we shall move on. Okay, crunch time as far as the hub is concerned. Clutch center. We're going to assemble the spline portion into the Yamaha hub. So I just want to make sure that I get this lined up. So bear with me, because there's method in this particular branch of madness. So let's just have a look on the other side where these two sets of material correspond. No limiting factors, so it's there and there, is there and there. So I'd like to line up two opposing splines, which will be there and there. So I'm just going to put some Loctite in. This is 601. It's a high strength Loctite. There's various different ones, different colours. This one happens to be green, but this is a high strength retainer. So I'll put plenty of that in there, because we can always clean the excess off later. And make sure we close it up again. I've cleaned it all up. It's been cleaned in the parts washer, and then it's had a good going over with some Loctite solvent, which is 7061 if you want to get some of that. It's quite expensive, and it basically is acetone in an aerosol can. So if you can get acetone in an aerosol can cheaper, you're basically getting the same stuff. So just let that stuff run around a bit inside. Make sure we've got it where we need it, and then we'll go over to the press and fit this part. Right, camera's not focusing particularly well, I don't know why. I'm painfully aware that I am going to be hideously in the way as we do this. I'll try, hopefully, to get you a good shot, but I think it's important that we get the job done right. So we're actually on a socket at the moment. I'm sitting on a socket to give us a bit of backup, and then we've got a piece of aluminium round bar as a buffer between the that's it, we're down between the ram and the part, so we don't mark anything, but that's all the way in. Pardon you. Right, let me get this back over to the bench, move the camera, and we'll have a look, see how well we've done. Right, back over at the bench, as you can see, I'm sure, and we're focusing much better. I think it's to do with the light over in that corner where the hydraulic press is. Not an awful lot of light, so I think that's affecting the camera. Anyway, here we go, and it's looking like a proper part. It really does look good. So that is our BSA splined portion in our Yamaha hub, and so that's located very, very well. It's a good fit, it's Loctited, but we're not just going to rely on that to stop it from rotating under torque. We're going to do something else, but we'll probably have to do that in the next episode, so I'll keep that one under my hat for now. We're going to do a little bit more just to sort of see how well we've done, loosely assemble it to the engine and just see how we get on with other parts. And I think we'll probably have to call the video there this week. I'm conscious of the fact that if I keep it under 50 minutes, it uploads so much, excuse me, so much easier to YouTube. If I go over 50 minutes, for some reason, it seems to take forever and I have problems uploading it. So let me just have a bit of a fiddle about. We'll assemble some bits together and we'll just have a look at it and sort of assess our progress so far. Right, here we are looking at the D10, and there's a little cup and a spring that goes on behind the clutch. I've just loosely fitted the clutch basket and the chain wheel, and I've just put the Kickstarter ratchet wheel on the back as well, just because it locates this spring, and that should, excuse me, that should give us the correct spacing for the primary chain. So if we just pop that on there, go on, you know you want to. There we go. So it wants to come off under spring pressure, but we'll hold it on. But so far so good. Look, we've got a clutch basket that runs on the shaft, so that's good news. We can just drape the primary chain over for now. There we go. Once we push that in there, the chain should line up. But as you can see there, no, you can't see a thing because the camera's too low. There you go. That's better, isn't it? As you can see there, look, we've got plenty of clearance between the chain and the clutch basket, so we're not going to have any issues there. Do you know what? I could probably join that chain up, couldn't I? Just temporarily. If you don't mind waiting, I hope you don't. Where's the other link? There it is. Well, I say I can do it. The camera's running, it's all going to go wrong. No, I think it's going to be awkward. Never mind, we'll do it without. Let's put our thrust bearing pack in, and then our clutch center, clutch hub, if you prefer. And hopefully, when we get all this pushed together, the two pieces will rotate independently of each other, and we'll have clearance. So let me just pull that in. Push that onto the splines, and there we go. It worked. Let me just move the camera and get you a better view, because I think this deserves a bit of seeing. Right, there you go. There's a slightly better view. You can see that we've got this recess here where we'll be making a sleeve nut, and that will fit in the recess, and we've got plenty of threads there, so we should get good thread engagement. It's all kind of balanced on there. The spring's trying to push it off at the moment. We'll make some final adjustments, I think, once we've got the nut made. I don't have the material for that just yet, so we can't do that at the moment. But yeah, we'll get the sort of backlash and everything figured out once we've got that done. I may have to adjust the end of the splined insert just to get a bit more engagement. well, not engagement, just to move everything inboard slightly. I'm not quite sure yet, or I may have to make a shim to go between the two components. We'll just have to see, you know, how much movement we've got once we've got it all riveted together and we've got the nut on. I think it's difficult to make assumptions at the moment because it's all just kind of balanced together. But as you can see, once the camera was off, I started performing a bit better, and I got the primary chain connected together. This is just an old worn out one out the scrap bin. It's not going to go on the engine. It's just there for illustration, really, because this engine didn't have one fitted. But yeah, everything turns. Obviously, it's not riveted together yet, so I don't want to put too much force on it. But everything turns. Turns the engine, turns the clutch, and if I just take the spring pressure off slightly, you can see that that turns with clearance. And we're running on the original BSA thrust bearing, so that's good. So, right, what have we got left to do? Well, we need to lock the insert against torque. We need to trim these fingers down just to make sure that it fits inside the casing. We need to make a nut, and we need to rivet it together. And I haven't got the rivets yet either, so that's another thing we can't do at the moment. One more thing I was going to speak to you about: heat treatment. You recall that I tried to anneal the insert. Well, I tried to anneal the spline, the splined hub, when it looked like this. Here's one that I haven't machined down. I have to say, I think that was a waste of time. I think the case hardened, and the teeth were very, very hard to machine. But once we got the teeth off and we got into the sort of the core of the metal, it was still very, very hard, but it machined reasonably well. You'll recall from earlier on in the video. I don't think that there's any need to do anything else with it. I don't think we took any temper out of it. I think it's case hardened, and I don't intend doing anything else with it. Well, I fitted it in there now, so I can't, but yeah, I think it was a waste of time to try and do anything with it. I think you've just got to persevere, machine it down, and just go from there, really. Of course, the ideal solution, if you're particularly well equipped with a broaching kit, is just to make a completely new splined insert, and then you won't have to machine one of these things down. And you know, if you particularly don't want to modify an original BSA part, yeah, if your workshop is well equipped and you can duplicate those splines, then that would be a good way of doing it. It would be prohibitively expensive for me to go out and buy a broaching kit, which I don't have, so that's why I didn't do it. Yeah, so that's it, really. As ever, thanks very much indeed for watching. Thanks for subscribing. If you're not subscribed, please consider it. We won't cost you a shilling, and if you click the bell, you'll get a notification every time I put a video up, and you'll be helping out the channel. So yeah, please do consider it. Like I say, that's it, really. Look after yourselves, and I will see you on the next video. Bye for now.